The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, good morning, good evening, all of you, wherever you are. It's exciting. This is Krishna Vedula from Indo-Universal Collaboration for Engineering Education, welcoming you all on behalf of IFEES, GEDC, and IUCE to another very interesting webinar. This is from our very important partner company of ours in Canada, Quanser. Very innovative company doing all kinds of interesting things, particularly in this new age. Some very relevant things are going on, applications. And so we have with us Peter Martin, who is the Senior R&D Manager for Academic Applications. And he will be talking to us, as you can see from the screen, about interactive labs for distance and blended control systems and robotics courses. So without wasting any time, I'm going to make Peter the presenter and let him take it away.
All right, there we are. Hello, everyone. Thanks for joining us today. It's a pleasure to be here again. And yeah, without further ado, we'll get right into it. As you can see here, what I'm going to be talking about today is a platform that we've been developing for about the last 3 or 4 months, building on obviously technology and a legacy of technology that's been years, if not decades in the making. But in this particular case, it is, as you can imagine, a platform that has come about, or at least accelerated, due to the current global situation that we're in. But you may notice, if you've been to previous webinars that I've done talking about this particular platform, that we've changed the positioning now slightly, maybe in light of in some regions at least of the world, an easing of the current situation, that we're now going to talk a little bit about the platform as a distance and blended engineering education platform. So we're not necessarily, and this was always the case, this was never a solution that we wanted to be a platform that would be used to address the need for distance learning and for off-campus laboratory experiences due to COVID-19. It was supposed to be a platform that we would release now to serve a purpose, and then build and grow and expand and hopefully become an integral part of both our technology platform and our approach to education, but also yours. And so that's where we're going now with the discussion that we're going to have today. And I have some exciting new developments on the platform that I'd like to share with you today as well. So we'll get right into it. The first thing I'd like to talk about is where I like to begin a lot of my presentations, talking about what we do as a company. If you're not familiar with Quanser, we've been around for over 30 years. We're based out of Canada, and we create what we like to call solutions for control systems, robotics, mechatronics, those sorts of STEM fields that are focused on the electromechanical and integration of systems and computation. But what we also do is we genuinely, and for the legacy of the company, endeavor as much as possible to prepare and to help our customers and our colleagues and our partners to prepare the next generation of engineering leaders. And as you can see here, there's a lot of different aspects of what it could be in terms of an engineering leader. There are a lot of different emerging technologies and future technologies that require leadership and technological know-how and a large gamut of skills and capabilities in terms of experience. And as much as possible, even since the beginning of the company, we've endeavored to create solutions and create platforms that can provide those skills and those foundations for learning and for experience that students can take into their futures, whether it be in academia or in industry. But again, as I mentioned a little bit earlier, this does sort of introduce the complication nowadays of how do you prepare engineering leadership and prepare students with the skills they need if they're not on campus, if you can't sort of follow the traditional pedagogical approach to engineering education. And with that, I'll talk a little bit about this particular question. This is one of our partners, Jinjun Shen from the UTIUS group in Toronto, Canada. And he approached us earlier in the year, as you can imagine, many did, to ask for any help that we could provide in terms of finding a solution to deliver complete online labs for the fall courses here in Canada. And this sort of prompted us, as I said, to look really really critically at our technological foundation, what we had built over the last 30 years in terms of technologies we'd released, that we'd brought to market, that were mature, that had a legacy of being able to provide these types of solutions to, as I said, to build engineering leadership, but also to provide solutions that we could take online, that we could pivot to provide solutions at a distance from a traditional campus scenario. And so the first question we asked ourselves was, if we were to build digital experiences, what we now call Quanser digital experiences, what would that be, and what would be the pieces of that kind of experience? And so we looked at, as I said, our technological foundation. Obviously, hardware is what we're best known for. We've been building hardware plants for robotics, mechatronics, and other primarily control systems based educational activities since the beginning of the company. Our first ever product was a servo motor. So we've been doing servo motors for decades. But then also over the years, we built up quite a legacy and quite a foundation in real-time control and rapid control prototyping on using our Quark platform. And then also what was a little bit less known was our technological foundation in virtualization and digital twinning, and sort of tied into a lot of experiences that we built up in the Unreal environment and 3D environments, using our overlap with our Quark foundation in terms of how we can provide the modeling and real-time dynamic aspects of those experiences. And then our QDex, or mobile content platform, that we built up over the last 7 years to be able to provide really enriched, engaging, and interactive experiences on mobile devices. And so these were sort of the 4 overlapping pillars of our R&D department and of our what we could bring to the table in terms of providing solutions. And as you can see here, I've emphasized to a certain extent the overlap between them, because that's really where we've started to be able to bring some of these products together and provide some of these products that I'll talk about in a minute, that really emphasize the crossover that happens not just in our group with our technological foundations, but also in the real world in terms of the complex system integration that's more and more prevalent in the growing engineering market. So in terms of Quanser digital experiences, the platform we wanted to build out in terms of bringing these technologies together, we wanted to fundamentally just provide a cutting edge approach to content, lab management, and distribution. So being able to have content and labs and experiences for students anywhere, whether it be in the lab, the lecture hall, their living room, online and offline, across a wide range of platforms and devices, but really to provide these solutions that were specifically designed for various courses and various activities. And that's something I'll emphasize, because you'll see as I go through these different technologies that we built up and talk a little bit about the one that I'm going to emphasize today, the Interactive Labs platform, there's a lot of different things going on. We have virtualization, we have mobile devices, there's the hardware, there's the real-time aspects, there's all of those circles I talked about just a minute ago. And sometimes they provide a really engaging and really exciting and really relevant solution for a particular aspect of a controls course or a mechatronics course or whatever the engineering course might be. But sometimes they're not quite as necessary. They don't quite have the real efficacy that you would need. And so what we try to do is blend them or provide singular solutions that are immediately relevant and immediately useful, and what is required to achieve the outcomes of the various aspects of the different courses that we typically provide solutions for. And to that end, the first one that we did that I've talked about in the past, starting at the end of last year, was our mobile textbook, Experience Controls. We've now had that out on the market for less than a year. It'll have been a year, July of this year. And in that basically one academic year, we've seen over 5,500 downloads, with 450 instructors requesting our instructor material. That's a wide complement of hundreds of pages and slides of material. And we've now reached over 60 curriculum modules that are provided as part of the textbook. And as you can see, the reaction that we got from students, these are mostly comments we've got from students just through the App Store review process. there's an appetite, there's a need for solutions that really push these aspects of engineering education and how content is delivered and how these resources are used in new and exciting directions to make them more interactive and engaging and exciting for students. And so this was really exciting for us, as you can imagine, but also really provided a basis for knowing that if we were to take these types of approaches to lab activities and resources for complex engineering courses in a new direction, we were confident that we'd be able to provide solutions that would really resonate with students as well as instructors. And the other aspect of the technology that I'll talk about is the digital twinning or virtualization aspect of what we've done over the years. This is an example from one of our partner institutions that's changing entirely how they deliver first-year engineering education. And this is just a small snapshot of some of the activities that their students do with, as you can see, a virtual replica or virtual hardware platform that replicates the experience they would have with one of our robots and the experience that they would have on campus with one of our robots. But an interesting environment where they're in a factory floor. If you could imagine this sandbox or small environment were to be removed, it could wander the factory floor and perhaps provide solutions to different warehousing challenges or things like that, that obviously have immediate parallels in the real world. And then obviously also in this case, it provides a venue for them to test their algorithms, to develop exciting algorithms for them and their groups and their project-based learning aspects of what they're doing. But again, also it gives every student their own experience at home, which is something that was really exciting for us to be able to, for the first time, have every student given their own robot, their own platform, their own experience, whether it be in a team or on campus or in their living room. And so if you imagine all of those circles I showed earlier and these aspects of the technology that we were bringing to the table in terms of how we wanted to bring together the content and the experiences for students, what we brought out for free trial when we last spoke in April of this year was what we really viewed as being the only hardware-inspired, scalable way to bring high-fidelity lab experiences to students off campus. Again, we're starting to talk more and more now about how these can complement learning activities on campus as well, or in a blended aspect, as I talked about in the title of today's presentation, where it's not just an off-campus experience with a student at home at their desk or as I am in their bedroom working on their engineering courses. This can be a platform that's versatile. It can be used in lectures. It can be used for on-campus augmentation of lab activities. It can be used in all sorts of different ways. And as you can see, aspects of it are completely cross-platform, macOS, mobile phones. You can use it on the metro or on an airplane. And so this was the platform that we brought that we thought would deliver these experiences. And then as part of this, as you'll see in a minute, we started to expand from there. We have a whole wide variety of aspects of different cross sections of what we've delivered that we've started to roll out since we first launched this a couple of months ago, to try to zero in on exactly what the needs are and exactly how we can address what students need in order to bring those experiences that they need to get nowadays for their ongoing skills development, and as I said, to make them into those engineering leaders, but then also how instructors need to be able to provide these experiences to students remotely as well as on campus. And so all of that typically begins with the current platform we have, the Interactive Labs platform, with our academic portal. This is sort of your starting point for any experience on the digital experiences platform. This is where students come to register for a course. This is where instructors can sign in and administer their academic session, whether it be adding students or looking at statistics for how students are using the applications. And then from there, the instructor workflow basically goes from, and obviously starting before that with a conversation with our sales team to really identify exactly what the need is and what the particular teaching scenario is going to be, through the academic portal, where students also completely on their own, if they don't need to be able to access the portal, can just download one of the mobile apps if that's appropriate for the particular course that they're going to be using, and register there without having and immediately see the content. So it's a very easy experience for students. And then finally, obviously in the application itself, for Windows 10 with the virtual labs, or on the mobile devices for what we're calling the essential labs, the the controls-based labs at the moment. To give them that experience and get them started, the process is realistically very easy. That's what I'm trying to show here, is that it's a kind of a 1, 2, 3 of for instructors, talking to sales, registering, and then being able to provide their content to students. And for students, it's even easier. They can go directly to a mobile app or directly to a Windows application. So I'm going to start a little bit now to talk more about the first product in the lineup, which is QLabs Controls. QLabs Controls was the turnkey platform. It was the way for us to deliver a controls experience, as I said earlier, that was tuned for what we saw as being the fundamental need of a control systems lab experience. And so some of the other things I'll talk about later today have a little bit more flexibility, a little bit more interactivity, where students can create, they can tinker, they can have an experience where they want to craft something. But for control systems, primarily the control systems experience, especially in undergrad, is based around parameterization and tuning parameters and observing the effects of different controllers at different gains or approaches to control on a plant. And so for that, what we provided was the easiest possible way to provide these solutions to students. And so QLabs Controls is that kind of interaction, that kind of engagement, but at the same time, it's turnkey. It can be provided on mobile apps, on Windows, on macOS, and you can do that without any need for support from an IT group, from any kind of resources on campus or anything like that. It's completely scalable. It can be provided to hundreds and hundreds of students. And as I said in the previous slide, they can do it very easily, just essentially by opening their phone or their laptop, registering, and immediately the content's unlocked and they're ready to go. And so you can see here kind of what that QLabs Controls experience is on both platforms. On the desktop, obviously, it's a rich 3D environment where they have a digital twin of one of our servo systems, and they can tune parameters, see the effects. We've done a lot of work on modeling our hardware, as you can imagine, over the years, to make sure that these are as accurate as we can make them to the experience that would be using one of our actual servo systems. And on the right-hand side here, you can see that experience on mobile, where the models are identical, the interactivity is there, it's running a real-time closed-loop solver exactly as you would expect, and they're tuning the same parameters, getting the same experience. The nice thing about the mobile side, you would have seen a minute ago, is that all of the curriculum is also bundled in there. They can answer check your understanding questions, they can see if they're really grasping the process as they move through it. There's assessment questions built in as well, and we're going to be hopefully in the next few weeks releasing an update to that experience where students can actually craft a lab report in the mobile app and submit it either through Google Drive or through email. So the mobile will really become a one-stop shop and a really simple and straightforward way for students to get those lab experiences exactly where they live. Because nowadays, as you can imagine, students more and more live on their phones. They don't necessarily have laptops or especially desktop systems anymore. But then if they do, and they want to have a much more sort of enriched and interactive experience on the left-hand side, they also have the option of using Windows or macOS to have a similar experience pedagogically, but a different experience in terms of being able to see how the hardware would function if it were really in front of them in a lab experience. There's a lot of different curriculum modules, as you would imagine, from Quanser built in, over 20 lab hours covering everything that would typically be included in an experience for a Cube Servo 2, from modeling and control through stability and parameter identification, getting into some of the more complex pendulum aspects of control and optimization, as well as measuring some of the properties of the pendulum. So a lot of different topics, a lot of different experiences, all of them either built into the mobile app or, as I said, on desktop, provided in an open format where they're just Word documents that you can modify and customized to exactly what your syllabus requires. And then also we get into some aspects of aerospace with our Quanser Aero platform, where we go through some of the same controls aspects as the servo, but also getting into more aerospace focused ones in terms of more complex optimal control of different configurations, as well as things like gain scheduling and nonlinear control. And all of that, in terms of the different packages, is also quite scalable. We're talking today for the first time about our classic controls bundle, which is a very simple and straightforward collection of just the servo motor experiences. It's still over 12 hours of lab experiences, and there's the ability for you to to have that for a 1-year subscription for up to 150 students. It still includes instructor resources. It still includes analytics and statistics on how the students are using the platform. But it's sort of an entry point into the experience where it's a very cost-effective way to be able to distribute this platform to your students. There's the core product that we bundled up, which is just the QLabs Controls bundle. That's the complete set of material. It doubles the number of students that can use it, and also delivers access to new curriculum modules we might roll out throughout the year. So anytime we deliver a new curriculum experience, that'll be rolled out immediately. And there's also then the introduction of a hardware discount incentive at the time of purchase. And then finally, we have the premier level where we introduce unlimited seats. There's a priority support where you'll be able to interact directly with somebody on my team if you have any issues. It includes what we're called the same hardware discounts at time of purchase, but then also it includes the introduction of what I'll talk about in a minute, which is our virtualization of the hardware, where you have QLabs Virtual QServo 2 and Virtual Aero, which introduces the ability for you to take those two plants that you just saw, the Aero plant and the QServo 2 plant, but interface to those 3D virtualizations and digital twins that are on the desktop from MATLAB Simulink, and hopefully in the future from other platforms as well. So that opens up the ability for you to access all the curriculum we've built for those platforms over the years, which, as you can see in the bottom right here, introduces another 50 curriculum topics that we have off the shelf that you can use. That's with the new release for the QServo 2 of our curriculum that boosted the number of labs we provide for that particular platform in the hardware world to almost 40 labs, which in this case is a great way to augment that experience, because anything that would typically work on the hardware platform will work seamlessly on the virtualized platform with the open virtual QServo 2 and Virtual Aero. The next product that I'll talk a little bit about, the next package, is QLabs Robotics. This is also going to be available next week as part of the rollout that we're going to be launching at the end of this month. And Robotics is the experience that I talked about a little bit earlier, which is essentially a robot for every student. And in this case, it includes both a manipulator robot, which I'll talk about in a second, and also a mobile robot. And they have, as you can see in the bottom right here, an experience where they can use them in an environment where they can reuse all of the curriculum we've developed over the years. You can develop your own curriculum. It's completely compatible with MATLAB Simulink using our Quark platform. But in this case, it's a Quark derivative, a license for Quark that's completely free. And the digital twins are fully instrumented and dynamically accurate, including all access to the sensors, the control systems, things like that. Again, anything that you would expect out of the actual hardware. And whether it's using our off-the-shelf experiences, or if you happen to have a QServo 2, or not QServo 2, sorry, a Qbot 2e, or our manipulator, it gives you the ability to reuse any algorithms you've developed over the years from MATLAB Simulink with that platform with very minimal changes to be able to port them from one to the other, which also gives students a really exciting experience where, as you can see here, the student experience for the virtualization platform, it starts with installing the software, opening up the MATLAB Simulink code that you have, updating it very slightly to target the virtual plant, and then running the virtualization system. But then once you get to the last step, step 6 here, there's always the bringing it back to hardware. And because we've done, again, as good a job as we can to make the virtual digital twin match our hardware experiences, once students are on campus or once they have access to the real hardware, they can immediately see the parallelism, and they can see how the algorithms they've developed at home can be applied to the real world, and maybe how they're a little bit different and how they need to modify them and adapt them. But as much as possible, we've made that experience of being able to take code from one side to the other and back again as seamless as possible. I'll give you a little bit of a taste of how that works here. This is one of our first tests of this system, but this, as you can see here, one of our engineers is, he's opened up the Interactive Labs platform for Windows. You can see here he's opened up the QArm workspace where he's going to work with some with our manipulator system. And here he's launching in MATLAB Simulink one of the lab activities for the QArm. So it's exactly the same code you would use on the actual hardware. It's behind the scenes, it's connected immediately to a dynamic model, running the dynamics in real time of the arm. And as you can see here, he's doing a very simple pick and place task, which is one of the culminating tasks in the first set of curriculum for the QArm that students are asked to do, is to build all the subsystems for a pick and place task to be able to have the manipulator achieve that particular goal. But as you can see, it's also very easy to use, very seamless, where you open the digital twin, it launches dynamics automatically. You open your MATLAB Simulink environment, make a couple of parameter changes, and immediately you're ready to go. The QArm itself, I'll talk a little bit about, just because this is actually an unreleased product. We're launching this in the next few weeks and months. But strangely enough, as all strange things have occurred this year, we're launching it digitally first before the actual hardware is released. So as you can see here, it's a completely academically appropriate manipulator. We designed it specifically for teaching, and specifically for teaching modern robotics, or teaching robotics in a modern way, using studio learning, using project-based learning. It's flexible and expandable. It's a 4DOF manipulator because for most things you would do in an undergraduate teaching environment, including projects, 4 degrees of freedom is more than sufficient to be able to achieve those outcomes. But it does have a very highly versatile gripper with the 2-stage tendon-based gripper. It also comes with an Intel RealSense camera to do some more advanced and exciting applications of machine learning and visual servoing and things like that. It has some capabilities that you would expect out of a manipulator like this in terms of payload and capabilities for reach and for velocities. All the typical sensing is built in terms of the joint positions, velocities, currents, temperatures, things like that. And as you would expect from Quanser, we also package up our complete curriculum mapped to traditional textbooks for manipulators, but also with some exciting project-based applications of the arm as well. And all that material, as I said, will be available for the virtual robot as well as for the actual robot once that launches later in the year. These are some of the topics that are going to be available for QArm. As you can see, again, they're the traditional topics you would expect in terms of joint control, kinematics, path planning, trajectory generation, things like that, dynamics and statistics. So everything that you would expect out of this particular platform, it has been bundled up and is available. And then for the other aspect of the QLabs Robotics Bundle, which is the mobile platform, you can see here we have a very similar environment where students can explore how to use the robot. They can get experiences. The sensor complement's slightly different. You can see here it's got bump sensors that are highlighted in the top. It has the ability to sense things like encoders and wheel drop and things like that. You can see an example at the top left of the camera system and depth data system that we'll be replicating. That'll be slightly delayed for the arm, but as you can see here on day 1, it'll be available for the QBot. And there's a lot of different things you can do in this little sandbox environment. We've designed it to be a playground for the curriculum we developed in collaboration with universities here in Canada, that covers all of the basics of what you would expect out of a mobile robot platform, things like line following, obstacle avoidance and path planning, mapping, and using multiple techniques for all of them, image processing. And so if you take this platform, which is essentially sort of an open architecture ground robot, you can apply whatever algorithms you like to it. Students can play and develop and really simply and easily understand how these algorithms affect the behavior of a mobile robot. But then you apply that to the teaching topics. Did I lose my screen?
You had a little glitch here. Just click show my screen again.
Okay.
Yeah, there you go. You're all set.
Okay. But then you can see with this platform, it's very easy to take that simple basis, take that essentially camera and sensor system on wheels and apply it to a number of different exciting topics, whether it be kinematics, mapping, computer vision, and path planning. And as you can see here, there's multiple approaches to all. Kinematics talks about both odometric localization as well as forward and inverse kinematics, as well as mapping, talking about occupancy grid, particle filtering, a number of different approaches to computer vision, and then a number of different approaches to path planning. But in all of them, everything is exposed, the same as with the ARM. So students can see exactly how the system comes together, exactly how the underlying subsystems and algorithms play together, how data is passed between the different subsystems, how the vision affects the mapping, affects the localization, affects the behavior of the mobile robot. The same as with the ARM, how the joint positions affect the behavior of the system as it's moving through a particular path or a particular trajectory. So there's a lot of different ways that these can be reused and repurposed, both in the virtual world and in the real world.
Peter,
but also,
Peter, we're just seeing your front slide. Is that what you?
Oh, really?
No, something must have happened to the presentation. Just go back.
Okay, let me try this again.
Yeah, full screen. Put it on full screen. Yeah.
Good. Is that good? Okay. But then again, it's
not on full screen. For some reason, it's not on full screen. That's why it's just showing everything else.
Let me try one more time.
Screen show, yeah, slideshow. Wait a minute.
There we go.
Yeah, now we're all set. Yeah.
Okay, sorry about that. But again, they're flexible. They can be used in a number of different ways. Students can see a number of different things. They can be used either virtually or in the real world for projects, for capstones, for a number of different applications. And all of this is, again, trying to deliver an experience to students that meets the needs of this particular type of course. We made a very conscious decision to make this that open and flexible and MATLAB Simulink, and hopefully in the future other platform compatible experience, because that's what's expected of a robotics lab experience. Students are meant to be able to create algorithms to see how they function on robots, whereas in the controls approach, typically students don't play quite so much in, for lack of a better phrase, the block diagram. They typically work on the parameter side, on tuning and understanding the effect of the coefficients and the models and the control gains on the particular hardware aspect, but building the algorithms, crafting the underlying subsystems isn't quite as essential as it is in robotics. But again, in terms of how this is packaged, it's packaged in a very similar way as the control solution, where there's a wide range of curriculum topics, a number of lab hours covering both of the platforms. This is available for up to 300 students at a time per year. And there's full instructor resources, access to new content modules, priority support, and then obviously, as I said, compatibility with MATLAB Simulink, and then hopefully throughout, as you'll see in a minute, the rest of the year, we'll be working to grow that compatibility, to make it more expandable, not just in terms of the experiences that students can have, but also how they have those experiences, whether it's with other platforms like Python or ROS or LabVIEW, but also how they can use the robots in different environments, as I talked about a little bit earlier as well. On that note, I'll talk really briefly about our timeline at the moment. This has been probably one of the most accelerated projects in the history of the company. We developed this platform in at least half the time of our typical development cycle, probably quite a lot less. So we've been rolling things out gradually, as you can imagine, once they're ready and once we can provide them as solutions. So that started in April of this year with the free trial of the Controls Bundle. Next week, at the end of this month, that'll be expanded to the full set of content that I just showed, as well as we'll be launching the QLabs Robotics platform that will include the products you see there, the QBServo 2, the Aero, the QArm, and the QBot 2E. The curriculum will be rolling out partially throughout the rest of the month. Most of the curriculum is ready for the controls platform. For the robotics platform, we're going to be launching with all of the applications, so all of the software from MATLAB Simulink to support the QArm, but that will, in terms of the workbooks and the instructor materials, will grow over the next few weeks. And then for the QBot 2, again, because it's based on all of our existing substantial curriculum for the QBot 2 for the mobile platform, that will be hopefully ready to go just out of the box with those seamless changes that we'll also provide as well. And then moving throughout the rest of the year, in August, we'll be releasing the virtual QBServo 2 and the virtual Aero to support the premier level of QLabs Controls. So that'll bring MATLAB Simulink support to those two products. And then in the fall, we're going to be trying to expand the complement of hardware that we offer through a different kind of more tuned and more flexible experience for partner institutions, where that complement of hardware gets expanded out to virtual coupled tanks, virtual rotary servo base units, ball and beams, flexible links, a lot of other hardware platforms to really complete that whole lab experience of having all this hardware available and being able to play with different aspects of how control systems can be applied to different types of servos, different types of time constants, different types of dynamic systems, things like that. As well, at that point, we'll be trying to expand the robotics package to have more extensive interactive and engaging environments, and possibly, we hope, the ability for them for different robots to be able to collaborate in different interesting ways, really to expand out that project-based aspect of that platform. And then finally, in the fall, we're looking at hopefully taking those hardware platforms that I talked about in number 3 here in September, and providing more flexible packaging for those in terms of being able to mix and match what hardware suits your needs in your particular syllabus, or the ability to replicate what you have in your laboratory so that you have very minimal changes to syllabus or existing curriculum. So that's our plan. As I said, next week is when the first part of that launches, which is the controls and robotics bundles. Those will be available essentially at the Monday or Tuesday of next week. We'll be launching those. And that'll start the availability of the subscriptions for 1 full year starting at that point. And obviously, if you have any questions about the particular packages or the particular aspects of how they can be brought into to meet your particular needs, there's a number of landing pages on our website that you can visit, as well as obviously contacting our sales support team at info@quanser.com, and they'd be more than happy to help. And with that, I kind of rushed through this a little bit more, but I'm more than happy to stick around for as long as necessary to answer questions.
Okay, thank you so much, Peter. Fantastic. A lot of exciting stuff going on, and we have a few questions already, and I encourage everybody to just jump in with a few more questions as they come up to your mind. Question here from Edris Ali about whether your system can be integrated into LMS systems that are being used by colleges around, like Blackboard and so on.
That's an excellent question. We've talked a lot in the past about LMS systems and how to integrate with them. My answer at the moment is realistically not entirely, because it depends on how that integration would work. The LMS systems have a little bit of complication, not just in interfacing, but also in privacy concerns and things like that, especially for the accounts management system that we have and things like that. Our utmost concern is student data privacy and things like that. So we need to be extremely careful how we bring in third parties and pass information back and forth and things like that. There's a lot of, because for the virtualization side, a lot of this is just sort of open content and open models that can be provided to students. That could be provided in the same way through the LMS systems, as well as on the mobile side, the submission of materials can be done probably through similar ways in terms of being able to have shared access to different cloud platforms like Google Drive and things like that. But realistically, we have it in the past, partly, as I said, for privacy concerns, and partly because institutions have different MSs, they have different needs, they have different ideas about what it means to interface to connect to an LMS system. And so that kind of complexity and multifaceted problem that applies differently to different institutions, to different education systems, is quite a big hairy can to open. So we have it in the past, but we'd be more than willing to hear exactly what the needs are and exactly what you're looking for, and we could try to provide something that could work, or at least build for the future something that could work.
Okay, we have a question from India, from Palaninath Raja. He has he's from Tyagaraja College of Engineering, and they have Quanser inverted pendulum and Quanser mobile robots. And the question, and I'm going to unmute him actually if he wants to follow up. The question is about accessing. Is it possible to access these apps and so on with the present setup that they have?
Hello.
Yeah.
Hello.
Palani, come in, Palani.
Yeah. Yes, sir. So we have in our institution Quanser inverted pendulum and two Quanser mobile robot. Is it possible to access our interactive robots with your app which you have developed already?
Like a remote access kind of experience.
Yeah.
It's possible in the future that we'll build towards that. At the moment, like my background, a lot of the work I've done over the years has been on remote experiences and remote labs before I started at Quanser. And so I'm more than familiar with all of the different intricacies and complications and challenges of providing remote labs. And so what we wanted to do with this platform again was to provide something that could work out of the box and that could be an experience that was easy to use across a wide variety of situations, whether students are on campus and they have VPN, or they're off campus and they don't necessarily have access. They have different machines, they have different internet capabilities. So that's the reason we went with the virtualization route, and the reason we went with trying to replicate the hardware experience for every student, no matter what platform they have. But I'm not going to rule out that in the future there wouldn't be the ability to have some aspect of remote experiences, remote connectivity. That's something we've talked a lot about, and we have ideas for how we could provide, but we're not there yet. Again, because it's a very difficult and multifaceted challenge, especially with limited access to campus for maintenance and support and things like that.
Fine.
Okay. So Ganesh, you want to talk? You said something about hardware in your lab being accessed. Do you have Quanser hardware that you have that you want to access, or I'm not clear about what your question is, Ganesh. That's another question, similar question maybe, but thank you, Palni.
Yes, sir.
Thank you.
Thank
you. Ganesh, you want to ask your question yourself?
Yes.
Yeah, go ahead.
Good evening, sir. My department has QBot robot, as Rajesh sir said. We are trying to access from my home to the lab, the same QBot to access. So as now I've seen some the same robot in virtual manner, but as speaker said, he's trying to interface with it in future. So that's what my question was.
Okay,
so one more question is like, you talked about some subscription about QBot Q Robotics Premier. Is there any payment towards that?
Yeah, so those different tiers that I talked about for the controls solution, these different tiers here, from the kind of the good, better, best of a solution that can provide classic controls to medium controls to premier controls. That's the sort of experience that we would have for robotics, where right now we just have kind of that middle tier of providing a fantastic starting point for robotics in terms of the arm and the virtual robot, with lots of different seats, lots of different flexibility on the lab experiences. But we would like this to grow into a top tier experience as well, where there's more flexibility in terms of how the robots are used, whether it's collaboration or students being able to access the same platform at the same time, or having more open environments where the robots have more ability to explore and do different types of operations and things like that. So that's the kind of experience we're hoping to provide. But again, that's a work in progress and something we haven't completely fleshed out yet. We haven't really decided exactly what that experience will be. But to your question, it will be those 3 tiers for controls, and once we have different tiers for the robotics platform, the different tiers for the robotics platform will be, there'll be different price points for that 1-year subscription.
Okay.
I can give you a little bit of a sneak peek of something like what we're thinking about for the experience for how students would, how that sort of top tier would be. So you can see here, I have my interactive labs open in Windows, and you can see here we have the arm, and we have the ground vehicle, the QBot. We have an open environment with blocks and pads. We have some modification to the QBot. So it's this type of expanded and more complex experience that we're hoping we'll be able to provide. Something like this, where there's more to do, there's more for students to explore and build solutions.
Okay. Another question from Sadanand is, anything associated with autonomous vehicles in your kit here?
Well, that's an excellent point. So again, that's something that we're hoping we'll be able to address in the future as we expand the types of hardware that we provide. We already have virtualization to a certain degree of our drone systems, the Q drone, and also we have almost complete virtualization of the Q car, our autonomous ground vehicle, the automotive self-driving car studio. We'll hopefully by the end of the year have a version of this digital equivalency where you can have different vehicles in different environments, and you can have virtual studios as well as having them in different environments and be able to do the aspects of self-driving vehicle research that you would expect. But again, that particular complement of exactly what's there and what's available and how it can be modified is something we're trying to really narrow down and highlight and build a solution that's going to be capable. And so if you're interested in that, we're in the middle of developing solutions for those types of things to replicate again our hardware, and we'd be more than happy to hear from you and exactly what you're looking for so we can add that to the list of capabilities we're hoping to have available.
Okay, here's a question from Velnath. I'm not sure I understand the question. He just says ball and beam with a question mark. And do you understand what he's asking you?
Okay, yeah, so the ball and beam, basically one of the hardware plants that we'll be hopefully able to start making available at the end of this year, starting in September and October of this year, is the ball and beam, which is essentially one of the add-ons for our rotary servo base unit. So the rotary servo is one of our oldest and most commonly used servo platforms. It's one of the more expandable ones in terms of being able to do different gear ratios, different inertial loads, things like that. And as you can see here, one of the add-ons for that platform, there's a number of different ways that it can be used. And one of the add-ons is this ball and beam, where students can change the dynamics to try to balance a ball rolling on top of a beam to sort of have a different time constant, be able to understand different aspects of cascade control and different control structures and things like that. So that's what the ball and beam is, and that's what we're going to be targeting as making released as part of the fall collection. Will be this ball and beam package to again be able to give an experience that's a little bit different from the traditional servo motor experience, with a different type of time constant and a different type of experience for students to be able to see a different dynamic challenge for them to take on for controls.
Okay, here's a question from Sri Devi. Question, I'll read it out. If we upload the code, will the arm or robot move virtually the same as the real one?
Yes, that's exactly the experience that we're going to have. So I'll just jump back to the video for the arm, which works exactly the same way as the robot will, and exactly the same way as the open servo and the open aero will as well. So here, again, in the background, my colleague is running his arm code, the same as the code he would run on his platform for the arm. And in the foreground here, the arm does nothing until this code runs. The arm just sits there waiting for commands, waiting for some MATLAB Simulink or other platform to talk to it, to give it commands. And once he's running that background code, that starts to communicate with the virtual arm, exactly the same way as it would communicate with the actual arm. And for the mobile robot, the experience is slightly different, because with our mobile vehicles, whether they're the drones or the ground vehicles, typically we would package up the MATLAB Simulink code as a real-time executable and cross-compile it to deploy it to the vehicle. In this particular case, it will be slightly different, where the code will run on your desktop and communicate with the virtual vehicle as if it were running on it, but obviously it isn't running on a virtual target like an Intel platform or an NVIDIA platform. But that is the same experience, where you can take your code, you can deploy it to the vehicle, and it should behave exactly as the real hardware would. Exactly.
Great. So we've run out of questions, and we have run out of time pretty much also. So I'm going to have Hans Heuer have the concluding words here. Hans, come in.
Thank you very much, Peter. Just a brief comment of just expressing our appreciation for your presentation, but also for the serious partnership that we've been able to develop, both the IFEES and GDC community at a global level with Quanser. Paul, and all of the team are just outstanding, serious professionals, deeply engaged in working with us at a global level. And I just want you to know, Peter, that we value it deeply, and your presentation is just another very excellent example of the seriousness of the relationship and contribution that you've made to our global community. Many, many thanks, Peter. We really value it.
Thank you very much. It's a pleasure.
Okay, thank you, everybody. I just noticed one or two questions that came in, but just you might want to email it to Peter, some technical questions. So please go ahead. One question came in.
Yes, absolutely.
Sorry. Okay, so everybody, thank you very much for joining, and thank you, Peter, for an excellent presentation. Take care.
Thank you very much.
Thank you.